Ever wondered what goes on behind the scenes when you write and run a C# program? At the heart of it all, we have .NET, a framework that provides a set of libraries and tools for building applications. One of the languages supported by .NET is C#, a versatile language developed by Microsoft. When you compile your C# code, it's translated into Common Intermediate Language, or CIL, which is then executed by the Common Language Runtime, or CLR. So, in essence, .NET provides the platform and tools for running your C# code efficiently and securely. Now, when writing C# code, you'll often deal with value types and reference types. But what's the difference? Simply put, value types hold their actual values. They are stored in an area of memory known as the stack. Examples of value types include integers, booleans, and structs. On the other hand, reference types hold a reference, or a pointer, to the actual value. They're stored in a different area of memory known as the heap. Examples of reference types are classes, arrays, and interfaces. But what happens when you need to convert between these two types? That's where boxing and unboxing come into play. Boxing is the process of converting a value type into a reference type. Unboxing, as you might guess, is the reverse, converting a reference type back into a value type. Remember, understanding how your data is stored and manipulated is key to writing efficient and bug-free code. Of course, no code is perfect and errors are bound to happen, but how are they handled in C#? In the world of programming, we broadly categorize errors into three main types: syntax errors, runtime errors, also known as exceptions, and logical errors. Syntax errors, as the name suggests, are grammatical mistakes in your code that prevent it from compiling. Runtime errors or exceptions occur while your code is running, and these are often due to unforeseen circumstances like trying to access a file that doesn't exist. Logical errors are the sneakiest of them all. Your code compiles and runs, but it doesn't produce the expected output. Now, how does C# handle these curveballs, especially the runtime errors or exceptions? With a mechanism known as try-catch blocks. Code that might throw exceptions is enclosed in a try block, and catch blocks are used to handle specific types of exceptions. Proper error handling is critical to building robust and resilient applications. C# is a rich language with many features. Let's explore some of them. Access modifiers govern the visibility of programming classes, methods, and variables. The most common are public, private, protected, and internal. The default modifier is private, meaning the member is accessible only within the same programming class. The keyword prevents a programming class from being inherited by other programming classes. This is useful when you want to restrict the extension of a programming class hierarchy. The params keyword allows a method to accept a variable number of parameters of the same type. This can simplify your code when the exact number of arguments is unknown or can vary. Speaking of programming classes, did you know there's a difference between a programming class and a struct? A programming class is a reference type allocated on the heap, while a struct is a value type allocated on the stack. Partial programming classes are another interesting feature. They allow you to split a programming class's definition across multiple files, which can be particularly useful when working with auto-generated code. The new keyword is used to create instances of programming classes or structs, while the static keyword declares members that belong to the type itself rather than to specific instances. A static programming class is a programming class that can't be instantiated and can only contain static members. Lastly, the ternary conditional operator is a compact way to evaluate a condition and return one of two values based on these features, among others. Make C# a powerful and flexible language for building a wide range of applications. And the C# language features don't stop there. Let's talk about the null coalescing and null conditional operators. The null coalescing operator, represented by two question marks, is a handy tool to provide a default value for a nullable expression. On the other hand, the null conditional operator, symbolized by a question mark and a dot, allows you to access members of an object only if the object is not null, preventing potential null reference exceptions. And then we have encapsulation, one of the fundamental principles of object-oriented programming. Encapsulation is all about bundling the data and the methods that operate on that data into a single unit called a class. It's like a protective shield that prevents the data from being accessed directly, maintaining the integrity of the data by hiding its internal state and requiring all interaction to be performed through its methods. That's a brief tour of some of the key aspects of C#. Remember, understanding these concepts is fundamental to becoming a proficient C# programmer. Happy coding!